Hey everyone, and we are back with the Hybrid Trends, and again back with Fleming and Hint. And we got asked about the performance running AI together with Azure Stack HCI. And I think, Fleming, this time you brought something for us to show that capabilities.
Yes, exactly. I think we spoke a lot about the capabilities of running inferencing on the Xeon CPU rather than some accelerators. And I just wanted to show some high level data so that you get a feeling on what kinds of performance are we talking about. So let me show you one slide. Okay, you can see this, right?
Yep.
Yes.
A lot of bars for
a lot
me.
of bars. So let me walk you through this. So what you see on this slide is basically the comparison between two Intel CPUs. You see the Xeon Gold 5416 versus the 8460. So this is a 16 versus a 40-core CPU. This is not the latest generation. This is the fourth generation, as is indicated by the second number here. Yeah, but it still, I think, gives you some very good idea. So on the y-axis, you see the throughput images per second. So we're showing you here an image classification benchmark, basically. Yeah, and you probably remember Hint was mentioning, you can, that quantization will have a big effect on the performance of these inference. So you see, this 16-core CPU can inference. Well, it's something like a couple of hundred pictures per second when you're using floating point 32 as the data type here. However, if you are quantizing this to bfloat 16 or even integer 8 by utilizing these AMX accelerators, because AMX, as Hint said in the last time, is optimized to handle these kinds of data types in the scenarios. You see a tremendous increase of performance times 4.9 and by 8.9. So you see we are roughly at 4,000 images per second here. If you're using, of course, the much larger CPU, in this case the 40-core CPU, the Platinum one, you've got even up to 10,000 pictures here, which you can inference per second. I mean, of course, this is dependent on the size of the picture and the resolution of the picture, this is basically used by a very popular benchmark here using ResNet 50. Yeah, and maybe Hint, you can elaborate here a little bit more on that one.
Yeah, so ResNet 50 is a deep neural network that has a convolutional architecture, and it's designed for doing image classification. So you feed an image and it classifies it to you, be it class A, class B, defined it on the predefined class that you trained your model to recognize. And yeah, as Fleming said, it's used quite extensively in benchmarks.
Yeah, and you see, I think the amount of images per second, it's quite a nice number. So it's definitely usable for a lot of use cases. Yeah.
Mm-hmm.
So that was the image classification. I've got a second example which talks about it's very similar setup, but just rather than looking after image classifications, we're talking about NLP, so natural language processing. Yeah, and here you see as well on the y-axis, you've got the throughput, samples per second, and here once again, through quantization, you are able to, achieve a substantial performance gain in this workloads.
Mm-hmm.
What I'm really find interesting here is, especially running on Azure Stack HCI, or it also accounts for Hyper-V in Windows Server, it's easier for us as an operating system passing those features through to the virtual machines, because we directly handle the CPU cores from the virtual machine. So there's no GPU partitioning what you would need to do with a GPU in between handling the AI workloads. So it really gives us a full option to handle everything through the CPU, and it also then increases the throughput if we can do that with the CPU directly. So that from infrastructure perspective, it's from my understanding and the discussion I had with my customers, is easier to handle. It's really no additional hardware required. There's no additional unused GPUs I would need to have in my cluster for those workloads. It's really like, yep, just put in. I'm again using commoditized hardware,
And it is, yes.
Yeah, and I can already run it, and that's really one fact I really like.
Yes, and you know what I think you shouldn't forget is, you know, of course these CPUs can be used to doing something, you know, useful, even if you don't do some AI workload. I don't know, you know, depending on how much AI workloads you're having. Yeah, so of course you can basically handle.
Yeah,
you know, all
just
sorts
stay
of
with
workloads.
our retail department. So I would maybe have my cluster running the image processing, the marketing apps based on the AI, and then I can still have my accounting software running in the market, just accounting what the customer bought and putting the numbers and putting my business intelligence behind it, and I can run it on the same hardware. There is no specialized hardware required.
Absolutely.
Or I can run it side by side with Azure Virtual Desktop. It's just again,
whatever makes sense. I mean, we can certainly help you to do some sizing to see, you know, how much is the workload you're having on these systems, how much can we load them, you know, what performance, what latencies do you need, and then we can help you to find, you know, the right CPU SKU for your specific task and make sure, you know, you are able to fulfill all these workloads. Yeah, that's something we can do.
Perfect. Again, thank you for that short call explaining the options here, and yeah, hopefully we get more questions to answer.
Yes, and maybe let me close with one last comment. So I mean, the data which I showed here today, remember, was measured on the 4th gen Xeon. 5th gen is already out. I didn't have any numbers, unfortunately, yet to share with you. But you know, the performance will be even higher on these systems. Yeah, so really something worthwhile looking into. So happy to hear from you soon, and yeah, let's do some AI on Xeon.
Perfect. Thank you so much.
Thank you.
Thanks a lot, Flo.
Fleming.
Thanks.
Yeah. Thank you. See you.
Thank you.